Chapter 2, Electrochemistry. Electrochemistry is the study of production of electricity from energy released during spontaneous chemical reactions and use of electrical energy to bring about non-spontaneous chemical transformations. Now, some spontaneous chemical reaction takes place which results in the production of electricity, and this electricity is utilized to bring about non-spontaneous chemical transformation. So, electrochemistry is the study of production of electricity from energy released during spontaneous chemical reactions and the use of electrical energy to bring about non-spontaneous chemical transformations. A large number of metals, sodium hydroxide, chlorine, fluorine, and many other chemicals are produced by electrochemical methods. Batteries and fuel cells convert chemical energy into electrical energy, and this electrical energy is used in various instruments and devices. Now, the reactions carried out electrochemically, they are energy efficient and less polluting. Therefore, study of electrochemistry is important for creating new technologies that are eco-friendly. So, why is the study of electrochemistry important? Because the reactions which are carried out electrochemically, they are energy efficient and less polluting. The transmission of sensory signals through cells to brain and vice versa, and communication between the cells are known to have electrochemical origin. Now, this is electrochemical cell. In this cell, zinc is dipped in a solution of Zn2 plus ion. The solution can be of zinc sulfate. Copper is dipped in a solution of Cu2 plus ions. The solution taken is copper sulfate. Now, in this case, this is the zinc electrode, and in the zinc electrode, zinc is going into the solution as Zn2 plus ions, and electrons are getting deposited on the electrode. This is the negative electrode, and zinc is acting as anode here, that is the negative electrode. And here in this cell where copper is dipped in copper sulfate solution, Cu2 plus ions from the solution are taking electrons from this copper metal and getting deposited on the surface of this copper metal as neutral copper atoms. Since electron is taken away from this copper metal, this electrode is positively charged, and this is known as cathode. So, the cell reaction is zinc changing into Zn2 plus ions, losing electrons. Slowly, this zinc anode dissolves, and copper as Cu2 plus ion from the solution is taking up electrons and getting deposited on the copper electrode as neutral copper atoms. So here Cu2 plus is undergoing reduction and zinc is undergoing oxidation. Zinc is acting as anode, copper is acting as cathode. Now, since the zinc electrode is rich in electrons, electrons are flowing from the zinc electrode towards the copper electrode, and the flow of current is just in the opposite direction, that is from the copper towards zinc. This is the flow of current which is in the opposite direction of the flow of electron. Now, this is the representation of Daniell cell. When the concentration of zinc and copper ions is 1 mole per decimeter cube, then the electrical potential of this cell is equal to 1.1 volt, and this whole device is known as the galvanic cell or the voltaic cell. This is the galvanic cell. Now, these two solutions are connected by salt bridge. To this cell, if external opposite potential is applied, then as long as the external opposite potential is less than 1.1 volt, that is the potential of this cell, the same reaction continues. Electron flow from zinc to copper, current flows from copper to zinc, zinc acts as anode and copper acts as cathode. But slowly, if the external potential is increased, this external potential is in the opposite direction. Slowly, if the external potential is increased and it becomes equal to 1.1 volt, in that case, no flow of electrons or current takes place and no chemical reaction takes place. Then, if the external potential becomes greater than 1.1 volt, the entire reaction starts taking place in the opposite direction. Now, zinc acts as cathode, that is the positive electrode, and copper starts acting as the anode, that is the negative electrode. Now the reaction is copper goes into the solution as Cu2 plus ions, and zinc ions from the solution get deposited on the zinc electrode. Now zinc ions take electrons from the zinc electrode, get deposited on the zinc electrode as zinc atom, and since the electron is taken away from this electrode, it acts as the positive electrode. And here, since copper atoms are going into the solution as Cu2 plus ion, leaving the electrons on the copper electrode, this copper electrode starts acting as the negative electrode or the anode. So now zinc is the cathode, copper is the anode, electrons start flowing from copper to zinc, and the flow of current is in the opposite direction, that is from zinc to copper. Now this cell is acting as electrolytic cell. Therefore, when the external opposite potential is greater than 1.1 volt, the entire cell reaction is reversed. Electrons flow from copper to zinc and current flows from zinc to copper. Zinc is deposited at the zinc electrode and copper dissolves at the copper electrode.